A very good afternoon to one and all present here. I welcome you all back to Atal FTP on 3D printing and design. This is session 12. At this juncture, we have with us Mr. V. Iraimudi, Head Healthcare Sri Rapid Technologies Chennai. He is sharing with us about application of AM in today's medical world with medical image processing and BioCAD modeling. I am very happy to introduce Mr. B. Iraimudi to the audience. He has rich experience in working with BioCAD modeling, image processing, and additive manufacturing. He is also being associated with market leaders like 3D System, Materialize, etc. He is a mechanical engineer by profession and completed MS by research in the field of additive manufacturing for medical application. He sets the trend in Indian medical industry by designing and 3D printing the first orthodontic splint in India for orthodontic surgery, facial corrective surgery using patient-specific data. Currently, he is Head Healthcare Sri Rapid Technologies Chennai. I welcome Mr. V. Raimudi and also thank him for sparing time with us. Sir, over to you, sir. You can start presenting your thing. Yeah, thank you.
Thank you, sir. Thank you so much. I would like to thank for the organizing committee and the institution for inviting me for the great section. And also I would like to thank Professor and Head Rajendran sir and also my friend and co-researcher Dr. Hariharan for inviting me. And also I think they started with it's a great section from my guru guide Ramikana madam. Probably ma'am will enlightened a lot of different sector with respect to research aspect and different applications as well in depth into the technology. And then Dr. Hariharan has give you a great information about how it works in a surface osseointegration, how it works on when placing implant is not a point, so how it's success. So we have to consider a lot of criteria. We have to consider a lot of limitations has to be taken care when we are coming to each and every application. Not it's common for all the application. Uh, okay, my topic is of course about today's trend in medical image processing and BioCAD modeling. Uh, I would like to give a no. It's not a kind. Uh, I'm not going to teach much like the previous section. They are expertise on that. So I just like to share my experience and like to show from some how it works. We know the technique, we know the process and how each and every technology has been using in different applications. So with respect to healthcare, 3D printing takes a big change. It's a game change. We can also say it like that. It changed a lot in their doctors' regular practice, and also a lot of there are a lot of changes in the improvement accuracy of the surgery. We are able to facilitate for the doctors, surgeons, with a great manner of information, customized way of treatment. Sorry, let me share a screen first. Just want to confirm whether my screen is visible.
Yes, sir.
Yes, sir. Okay, fine. Yes, okay. Yes, and also okay. Myself, Iraimudi, I'm representing company called Sri Rapid Technology, company who represent additive manufacturing more than 15 years. And I would like to introduce our founders of the company, like Nitin Chaudhary sir and Sashidhar Kumar. They are the one who promoted the technology very first in India. Okay, they have been associated with this technical technology, lot of OEMs, more than 25 years. And also our ultimate goal is not to giving a one point solution, we have to give a complete solution rather of giving only the machines or only the software. With respect to all the industries, we would like to propose, give a complete solution rather than the way of, setup, technical assistance, research, and everything. Because, one of the great example is, of course, a company who more focus on research and promoting the technology in a right way. This example is, our company, we have invested nearly, 12 to 13 crores to set up a customer innovation lab in India. It's in Mumbai. We have nearly 14 to 15 3D printers, all different technologies, starting from liquid base, powder base, metal. We have metal 350, DMP 350, 3D system machine, and we have a lot of different machines over there. The ultimate goal is not a service point. I'm talking about a commercial service, printing service. It's purely for demo and also for research purpose. So we are open to work with the colleges, students, researchers to support them, not taking a point, like a commercial revenue. We are open for research, and also I would like everyone invite to come and see our facility. You can, see experience, and you can also demo them. Okay. We present pan India. So I'm located in Chennai, but our head office in Mumbai, and also we have a regional office in various places. Brands we represent, okay, of course, as I mentioned, no, we always work in an end-to-end solution. Like we are representing multiple of brands, multiple of technologies, but we never repeated the same technique with the different companies. And with respect to healthcare, probably I can pick it out, no, 3D systems, 3D Ceram, 3Shapes, N-Topology, FabPro, sorry, Formlabs. So these are the things, and also Microbes trucks are the different technology, Dimension and Cartesius, they are post-processing machines. There are various different things out there. So coming to topic, of course, please let me know if you lost my audio or screen sharing or something. Please intimate me.
Yes, sir. Yes. You go ahead, sir.
Yeah. Okay. So medical additive manufacturing. Probably you may had a different section with very eminent professors like Vinod sir. Probably tomorrow Rajesh sir is giving a section. Each industry have their unique way of utilizing any new technology. When we talk about healthcare, of course, healthcare 3D printing takes a big change in the healthcare practice. And also the main thing I always point out is when we talk about automobile, we aerospace, or any mechanical base, or of course, when we talk about civil construction, food industry, there is always a single department who work on that. Probably we may take little bit support from the electrical department, those things. But in healthcare, I would like to mention, like, it's a kind of interdisciplinary work, okay, because the end user is a surgeons. Okay, so we have to develop, we have to create something, we have to invent something that has to facilitate the surgeon, because the information is more important when talking about the surgical aspect. We have to give them the better information for diagnosis purpose, and also we have to give some surgical assisting models, and also some kind of devices has to be give them a wide way of achieving the achieving accuracy in the surgery. And also when we talk about healthcare, one more thing, I would recommend probably 3D printing as a, of course we always have a discussion about a difference between conventional and 3D printing. Okay, so far 3D printing has been in healthcare using more on customized treatment. Hope you know what is customization. Single patient, single data. So we do a specific design development, any diagnosis, and we treat for it. So the thing is, it's not like other industry in healthcare. Every day, every case, even if it's a model, even if it's an implant, each and every case is an R&D. Okay, so we can't keep a same methodology for all the patients. We can't go with, for example, if I'm designing a cranial implant, okay, so each implant will give me different complexity. Okay, because it's a non-parametrical structure. Each and every time I used to struggle with, some point, and next case, I can be expecting, this will be a difficulty, but in that case I don't face that difficulty. Okay, that the difficulty may come into the different point, different stage. So probably I may, face a lot of problem in creating a structure, achieving the symmetricity, taking a reference. So that what I say is, of course, it's an industrial work, but we do most of R&D work of each and every case. Would say like, I learn every day. So every day we learn new things. Issues that we are facing it out. So I just, of course, it's not a kind of, product way. I always recommend this the way of workflow. Okay, here you can see a 3 different workflow. One is a reconstructive surgery workflow, like models, reconstructive surgeries, bone reconstruction. Probably there is a defect in a internal organs or something. Any reconstruction surgery or any treatment-based surgery. This is what the workflow. And then the second workflow is for prosthetics, external prosthetic and orthotics. The thing for a dental. So this is a complete workflow for all healthcare department in 3D printing technology. Okay, as I say, we can call it as inputs. Okay, likewise, of course, this is also reverse engineering. So that's how it will work as well. The input data probably, based on the department, it change. Like, if it is a reconstructive surgery, the input data should be a CT scan, MRI, CBCT. Okay, and also for prosthetics, we will take a scanning of a patient, by external surfaces, by the 3D scanner. Hope you're aware about it. It will give you information of the external surface, not internal. Okay, the third thing is dental. Of course, dental, more people are aware about the dental. So taking an impression of the tooth, they will scan it. Of course, the new technology is intraoral. So we don't want to manually impression taking those things. So they can have a small, here you can see the picture. So they can have a small scanning camera. So then they can directly scan it through the mouth. Okay, so they will place into the mouth and they will scan it. It will scan the tooth and your soft tissue region as well. And then the second part is designing. Okay, designing, of course, there is no one software, there is no one technique, there is no one designing tool. There are a lot of companies, a lot of brands are there. They are representing and they have their unique pros and cons, of course. Okay, so the third thing is printer and materials together, as I say. Okay, so this is how it will work. For reconstructive, this is what the workflow, data, image processing, and BioCAD modeling, and then 3D printing. So probably we cover this topic more. And also, I would like to give small idea about not about the technique of the machines. I would like to show what technique I prefer for each case. What material I prefer for a different cases. What are the materials available in the market? Because research, of course, one. If I have an immediate case, so how I can choose it, how I can prefer it. So even if we are going to having a research idea of developing a material, developing a machine, so we have to know existingly what market people are using it. Then obviously implementing, putting into the patient, doing the surgery, that's what it's for. So 3D printing, implants, applications, head to toe, lot of opportunities there. We can say it as a 3 different classes. Okay, first thing is model. Probably model, we can say it as like a defective model. Where is a defect? What is the size of the defect? We can measure, we can plan. They can do the mock surgery. Okay, before operating, they can trial it. They can cut it. Doctors will have a complete idea about what's going to be inside the body. Okay, there is no surprises. Okay, the surprises is not a I won't say it's a good surprise. It's a critical surprise. Okay, so when they open, they feel some new surprises that may increase their surgical time. They should have some other idea, planning of doing a procedure. So they have to change it. They have to spontaneously print it. Sometimes they may be limited with the equipments. They have to get the equipment in that period of time. The patient has to be in the anesthesia itself. It's everything causes, issues, delays, a lot of things. Okay, models will avoid everything. They know the information exactly. They can diagnosis prior to the surgery. They can find out. They can go with it. Second thing, instruments and implants. Of course, when you talk about instrument and implants, it's more important. We have to talk about materials. Okay. At the same time, even not only the implants, even for a model we have to consider about the materials, because lot of government is coming up with rules and regulations. We can't use any material for the model because few materials we could not able allowed to get into the operation theater. Probably if it is a prototype, it is a model, they are just going to do it outside of the theater. They're not going to use on the patient or into the patient. We can use any material, any technology, but when it comes, we are going to use it for real time into the theater when doing a surgical planning. So it has to be get into the theater. So for that we have to be choose the proper material, has to be compatible. So when you talk about compatibility, there are two different things. Probably I will tell you later. Okay. Third thing is high risk devices. Probably, we can say it like, instrument and devices are totally different. Instruments, implants and instruments are more on using, to placing something or place something. Okay. But devices, always it will help you like, cutting guides, like jigs and fixtures, something like that, cutting guide, removal guide, placement guide, something. It guide you. At the same time, it will give you more, accuracy on the placing of implant, cutting, removing of the defectivity, something like that. Whatever, maybe it will give you the proper, cutting phases. So these were the three main applications. Probably you can see it as a products. Okay, in that there are a lot of different things that are based on the, each and every speciality. If it is for a craniofacial, it will be different. If it is for a spinal, it will be different. Sorry, it is for other orthopedic and any it depends. So this is what the major workflow that we are going to cover it today. As per the topic, it's image processing and BioCAD modeling. So image processing, this is a part how it works and everything. After that is BioCAD modeling. It's a large work, lot of things has been come into the process. Okay, and then we can go for further. Okay, so what is image processing? Image processing is a common term. Probably, when we are purchasing something in a supermarket, they are scanning your barcode. That's a kind of image processing. Toll gate, when you're going for the fast track, that's image processing. But it's a medical image processing. The term defines like, it will process the image from 2D to 30. Okay, so information and input data is from CT, CBCT and MRI. Any scan data we can convert into 3D model. Okay, that's how medical image processing works. Okay, it's not a step process. There are a lot of different methodology has been used before, but currently to reduce our time, reduce our give more accessibility, giving more accuracy, there are a lot of softwares in the market. So you just want to get the data of the patient like CT, CBCT or MRI in a format, then you can import into the software, then you can convert it. Okay, once you convert the model, then if you want to print only the model, as I told you, models, any defective model, they want to print a specific region, more on region of interest that doctors need to do it for diagnosis, so that you can cut down and you can choose the material, you can print it and deliver it to the doctor. Okay, if it is the requirement of designing a surgical guide, doing a virtual surgical planning, so to understand the surgical complexity and also to design implants, okay, patient specific implants or standard implants, any implants. Okay, for that we need a BioCAD modeling. We are going for the BioCAD modeling. BioCAD modeling, of course, you may have a question like, we have a lot of CAD softwares, why can't we use it? We can, but we can't use it for all the applications. So I will tell you later. Okay, so BioCAD modeling covers everything: design, development, structures involves, support structure involves. We have to consider everything together, and then you can go for the printing. And also, as ma'am in told and also Hariharan has mentioned it, in medical application, software, of course, in the complete additive manufacturing, software takes a major role. And with specific to medical, of course, software takes a very, very important role, because it has to be go in a proper way, certified process. Because of course, in some other application like automobile or something, we have a component. For example, if I'm scanning any engine part or something, I can do the 3D scanning, so I can get into the software. So I will do the parametrical measurements in a software, and I cross check it. Okay, we have tolerance, of course. We cross check it, and I'll be very sure about the accuracy of the data that I am captured into the digital form. Okay, because I have a real component in my hand to compare, measure, cross check. Okay, but in healthcare we don't have nothing. We just take a data, whether we are not sure the converting data is accurate or not. That's one important point. That's coming to the certified software. Okay. Then you are designing, we have some limitation. We can't show our complete creativity. Of course, we can create anything, but with a limited surgical aspects. Okay, we have to consider that. And then before that, okay, this two part we are going to go in the deep understanding. Okay, when talking about image processing, there are a lot of softwares in the market. I think more people are aware about Mimix, Materialize. Okay, of course, I'm a well user of Mimix from 2010. My research is based on Mimix. It's Materialize based, so they have a designing tool. A lot of things are there. And also now there are a few more softwares are coming in. ScanIP is one software. There are free source softwares are there. It depends. If it is of research, is not a point. You can use any. I won't say it's just for a model purpose. Okay, but when coming to the real cases, we can't use all the softwares. We, of course, as a company, we have some restrictions. As a as a medical fraternity, we always consider about the certified process and something we have to do, because it risks a patient. That's a very important thing. Okay, in medical image processing, the software that I'm using is D2P. It's DICOM2Print. The name itself defines what it will do. Okay, as I mentioned, image processing software will help you to convert CT scan data into 3D model. Okay, what format that I can import it? That's a very important thing, because usually the doctors are using a different format. They have some basic software to visualize, understand. Okay, when it comes to image processing, the data has to be exported into the DICOM format, digital image communication on medicine. Okay, so this is what the format is universally accepted when applicable to convert any DICOM data into the 3D model. Okay, not one specific single software. In all the software, DICOM has to be converted as a 3D model. How it works? Okay, for example, if I'm taking a CT scan of a skull, my complete head. Okay, my head is, of course, I can consider 30 centimeter, like 300 mm height. Okay, if I'm taking a CT scan, that instrument will capture my image in all the three views, like front view, top view, side view. In medical, we say it like sagittal, coronal, axial views. Okay, it will capture in all the three different views, and it will give you slices of data in a 2D, okay, in DICOM format. Okay, the slices size will based on the machine or based on the parameter that we're fixing when we are taking the scan. If, for example, if the scanning is taking of 1 mm of slice thickness, okay, I will have 300 slices in my hand in DICOM folder. Okay, probably you may more aware, you may see some CT scan data. Probably doctors will have that black and white sheet. They will see where is a fracture, everything. Most things the doctor will have a specific defective portion. They don't have a complete data. Probably they know the CT scan, the specific doctor, radiologist. That's their job, is they have to find out the defectivity, where all the fractures are, where all the defectives there. They will take the particular slices and they will provide the information along with a picture to the doctor. Okay, that's a single slice. Like that, we will have a 300 slices if you're taking a CT scan. What the software will do is, it will import the 300 slices and it compile as a mesh, and then using that mesh, we can convert it as a 3D model. That's how it works. For example, if the data is not perfect, there are missing of slices, the software, now with the advanced software, it will show there is a missing. Sometimes a missing, if you want to go with some research cases, it's not a big deal for you. It will also, in D2P, it will also ask you, can we compare it again? Okay, it will interpolate with the missing region with the existing data. Okay, but it's not advisable for the medical practice. Okay, maximum, very rare cases it may happen, but maximum of CT, CBCT will get a proper data. So the software will help you to import the DICOM data, number of slices, and help you to convert as a 3D model. Once you convert a 3D model, then we can do anything. At the same time, as I mentioned before, the quality of the data. Okay, as I told you, we can't find the mistakes. Okay, for example, if I'm converting a data in a software that may not be a certified one, okay, probably the data converters are be scaled down or scaled up, even up 1 mm or 0.5 mm, whatever it may be. I could not able to find the error, because if I want to find, I have to cross check with the patient. I have to open it and see. It's not possible practically. Okay, so I have to go with it. For example, this implant case. It's a jaw implant case. So I'm converting the data, printing a model, designing an implant, going to print an implant of 1 lakh or something. It's a price or value. Going to print it. We fixed all the surgery. When the doctor cut the mold, place the implant, it won't fit. The only point we find the error is the end step. Okay, at the time we can't change anything, we can't edit anything. So that's what, when you choose the image processing software, you have to be very careful on picking up the certified software. That's how the FDA clearance, CE mark. There are a lot of things that each country will have their own thing. Currently, these are the main thing, the European based certification that we have it. We can use this, and also I think one more software is also having a same certificate. We have D2P is having a certificate. Okay, and the same thing when we talk about the conversion. Okay, there are different way of image processing is there. Okay, as I told you, like it will capture the data from the CT, CBCT, MRI. It will convert as a 3D model. Like that, we have a different parts, like different kind of changes. That bone is a completely different threshold range. We can also mention like density. You can do that. Consistency. Okay, soft tissues there, nerves is there, internal organ is there. So that's why we have 3 different modules in image processing. The software, like bone model, vascular model, and tooth model. And also like a tool is more on visualization. At the same time, we have some different tools to cut the model, to prepare the model very quickly. Okay, because managing with the bulk data, it's initially it's a very big task. For example, initially if I want to convert the data, we have to fix the threshold value. Sometimes we will have, for example, if a case like that, there should be some screws and plates. When we are taking a CT, there should be some scatterings. Okay, so that scatterings we have to manually remove it. We have to work on the whole 300, 400 slices layer by layer. We have to edit it, remove it. We, as engineers or biomedical engineers who are working, we are not much well versed on anatomy. Of course, we have to learn it. If we miss it, the whole things get failed. So that's what, it's an automatic tool we have. So it will remove the scatterings. It will separate the bone and do a lot of things. And also we have VR, virtual reality together. Okay, it's an advantage more on surgical aspect. I just give you a small idea about it. Quick understanding of defectivity, abnormality. You can measure it. In image processing software, you can also do a planning, basic planning. Not designing something. You can plan something. You can plan. You can cut. You can remove those things. And also you can separate the existing screws, plates, because that's works in a different threshold range, density probably. Bone will have a different density. Screws and plates will have a different density. So for some kind of complicated cases, you can manually extract, remove, and you can replan the surgery for the next step. And separating the bone, of course, as I mentioned, you can separate each and individual bone quickly. You don't want to work on each layer. We have an automatic segmentation tool. Okay, so this is what the bone model, as I mentioned, automatic segmentation tool will help you to convert bone automatically. At the same time, separation of the bone connectivity for probably, I think you are able to see the points here, plus and minus. So if you want to remove the connection, if you want to separate the bone where it is connected, you just want to pick a plus and minus point. So the software will automatically generate and it will separate. Okay, accurate process. Okay, it will separate automatically. And also recently we launched machine learning, MI, that's along with the artificial intelligence. So you can, for example, if you are importing the data like this, so within a single option, okay, the software itself convert automatically your bone, your tooth, your nerves. It will separate automatically in 3 to 4 minutes. It's a machine learning. Recently we launched it. Okay, it reduces a lot time. For example, working 1 hour of time, so you just finish it in 2 to 3 minutes. So because we can't spend much time on conversion, so no more. Okay. And of course, tooth model is more on dental factors. You just separating the tooth is a big task. The same, we have to work on layers. We have to consider about the tooth composite levels. Sometimes they will put composite, some kind of filling regions that act as a different density. It's a long process. Sometimes it's not possible, but these tools will give you just, you want to pinpoint what region you want, what other tooth you want. So once you apply, it will automatically process and remove the tooth from the bone. Exactly. It's called, in medical term, they will call it as extraction. Like probably few people may not experience with extracting, they're removing a tooth. So something like that we can do digitally. Vascular, of course, more interesting point. More complicated surgeries are happening. Um, I think yesterday, yeah, we printed a heart model. Sorry, I wouldn't add it. We printed a heart model for two walls. They have to operate it in Ahmedabad. So we segmented using the software very shortly. We printed immediately. It takes 5 to 6 hours for us to print in one of the printer that we have in Mumbai. So it serves a lot. Taking a heart model along with each bronchioles over there. Very minute arteries are there, so we can take it very easily, quickly. You don't want to worry about it much on that. The two things is, when we talk about this specific software D2P, okay, as engineers, as biomedical people or mechanical engineers, of course, we don't know anatomy. Okay, so we are not much practice with them. We can learn it. That's not a problem. Of course, I too I learn a lot. It takes time, but of course, based on the practice and the experience, you can learn it. At the same time, this software will not give you more struggle for you to find out the which bone, where is the connection, how it works. So since it's it just only you can have a basic ideology about the each part, so that this automatic tool will always help you to segment, remove, do things very quickly. One point. The second point, if the user is a doctor, okay, so they are not much practiced with the CAD tools. Like, they are not much practiced, they are not much user friendly for the softwares. Okay, if they want to do some 5 to 6 steps, they will get, even they don't have much time to do that. Okay, that's in that point, this software will help them to do conversion in a single step. Sometimes it take only 2 to 3 steps. Some examples, probably you can see it here, the internal data vascular region. So you can see some cancer part here. Of course, you can see some multicolor. I will say, what is it? Okay, this is lungs. Probably we worked a lot in 2020 when COVID came, attached with some US-based hospitals. I got the opportunity of working with 3D system to convert few data in their initial research. So we converted lungs, COVID infected lungs data. I can't share it in presentations, but it's a good experience, of course. More detailed information, the volume, how much the lungs has affected. We validated a lot of things. If I want to talk about it, it takes another section, but it's a big learning curve for us to to help the society in a right way with the softwares like this. As I mentioned, different colors. Okay, when you talk about the color difference, the software is automated. It will give you some color. It looks a little real. Okay, the color will vary based on the thickness of the bone. Okay, if the bone is more thinner, not only the bone, any organ or any part we are converting, it's a more thinner, it comes in a red color. It's more thickened part, it comes in a white base, some ash color, something, a brown color, something. Okay, so that's what you can see, a different color in each converted data. Okay, it's a very thin part, so it's come red color, it's multicolor difference. Okay, of course, we can also remove the existing screws and plates or implants, exactly as I mentioned before. Of course, as I mentioned, we also have a few editing tools. Probably you can do wall thickness, research base. Okay, now our new version, we are also giving access for you to export any bone data, any CT scan data. You can convert as a IGS file. Okay, that's a new thing that we are doing. So you don't want to convert as a 3D model. You can even convert, export IGS file from the mesh. Okay, so that works a lot in analysis part, validation, development part as well. So virtual reality, of course, it's more on teaching aspect. VR is option. You can convert any bone data as a 3D model, and then you can go into the VR. You can see it in a virtual reality using the joystick and those things. And in few cases, this is advanced VR, so you don't need to convert and do a lot of work. So you directly import into the advanced VR model, the complete DICOM data. The model will give you the complete information along with the soft tissue, hard tissue together, nerves, everything. So you can do all the work and all validation in VR itself. It gives a lot of tools. So it's a very big experience. So this is what image processing will do. Image processing, probably with respect to the software that I'm using, there are a lot of softwares. It depends. You can use any software. I won't say, wrong to that. But only thing, if you're going for a real case, please consider the some certified software aspect. Okay. And G2P, we will help you to convert a 3D model as basic planning, segmentation, conversion, VR. This is what do. As I mentioned, if you're going to print a model. Region of required model, specific model. You don't need to print a whole model. We don't need to waste the material as well, time. So we can be more specific on required region something. Okay, you can go for the printing. If it is required for designing, virtual planning, surgical guide, something, that's a part of BioCAD modeling. Okay. Okay. When you talk about BioCAD modeling, probably everyone have a question, sir. Why can't I use CAD softwares? Okay. I tried a lot of CAD softwares, okay, don't need to mention a name. So practice in our regular mechanical, we do lot of CAD software. Few softwares will support, few softwares will not support. Few softwares, maximum of softwares are supporting. Sometimes they will take STL file. Now I hear that new versions, few softwares are having an option of putting STL file. But when we are importing that STL file, we have to be very clear what is the quality of the data transfer. Okay, for example, if it is a skull, okay, any region, if the skull is deformed in the surface, okay, because sometimes it works on an IGS, then you have to come into the surface, it will construct surface automatically. That won't give you the exact accurate data. There should be some deformity variation, something like that. I don't say some, a lot of things are there. Whether it is some new version, I'm not aware about it. But if it is a new version also, that no things has been certified to use on that. Okay, even no one will certify for the designing software because design may vary based on the designers, based on their skill. But we can say like which software will adapt or import the data accurately what we are getting out from the image processing software. Okay, as a STL file format. And say one more thing I have to mention. In D2P, since it's all 3D system based software, 3D system is the only company having a end-to-end solution for healthcare. Okay, when you're converting a data in D2P, you can directly transfer the data into freeform. We have an option of direct clicking. There is a button, so that will show you the freeform name. So that you can click it. So the data that you're converted as a 3D model is directly transferred into the freeform. Then the screen will open. You can start designing and everything. One part. Then another part you can export as a STL file. You can import wherever you require. You can import and you can do it for the design. The main thing is this anatomical organ structures are more on non-parametrical surface. We can't create anything on parametrically. At the same time, no, we can't use or develop or do things with primitive shapes or structures or anything, any primitive, whatever with the step. We can't do those things for a kind of in healthcare anatomical design application. So it needs a kind of organ shape, free access or free form to design things. Okay, that's how it will work. Um, this software is not exactly developed for initially developed for a healthcare. They have been developing this device come with software for a sculpting industry, toy industries. Okay, they are using for some other for foundries, those kind of things. Okay, in 2016, of course, I worked in a different company at the time, so we heard about it. We saw a demo, and we are interested, and we started working with 3D system. Why can't we get into the healthcare? This software. So we started working with 3D system, and we developed a few extra, not we, 3D system developed. We associate with them. They have supported a lot for us to do all R&Ds on that. So initially we started doing small models preparation, guides. Now within a year we started doing implants. This is a software. When okay, maybe you have a question. Okay, is there any other software? Yes, of course there are a lot of software. When I give you some, okay, I can't give you a overall idea about you can use that this and thing. So I always prefer to share my experience. So I am using this software for 5 years, 5 to 6 years, almost. Design roughly. I'm not sure the numbers now. Roughly, I have designed nearly 250 to 300, 250 to 260 something numbers, patient-specific implant by using the same software. Not me, and also my friends, colleagues in the industry, they are doing everyday lot of implants since I'm not a service provider right now. So it's worked pretty well in a different way. That's also we have a much access. Excuse me, much access on designing more organ shapes. And one more thing, this software comes along with a device. Instead of mouse, you have to use the device. It's a haptic device, will give you the haptical feedback. Like since we are designing, developing something, it's non-parametrical. So we have to be understand how it works, how it touches, where it, the bone density. You will get exact, feedback. You can cut the bone. You will exactly understand the bone anatomical, whether it is thin, thick. Maybe in bone we take it as a cortical bone, cancellous bone, like probably in chicken we have so bone marrow, internal things, so something like that. So hard bone, soft, something like that. Based on that, it will give you the touch feedback of consistency. So that okay, simply like when you're cutting a cake, you will feel the consistency of the cake through the knife. I think somebody is unmuted. Yes, fine. Thank you. So, like cutting a cake, so you will feel the consistency, hardness of the cake through the knife, something like that. So, same, it will give you the consistency of the bone or any data that you're importing, surface roughness, you can touch and feel. You can do the cutting. Probably for doctors, we advise them to do the virtual surgery. So, they will get an exact feedback of cutting a bone, removing and placing an implant. They can practice it. Okay, they can practice for a teaching purpose, they can practice for the real surgical purpose as well. For engineers and people, we really have more confident on designing a shape structure because it's non-parametrical. We know how it's symmetric in the shape, how it's adapted into the bone level. Okay, how it works in that way, so that we have more confidence on that. So in BioCAD modeling, the reason, okay, I think I left the point. So the reason is why we prefer this kind of softwares, because the softwares will give you the data transfer more accurate when we are importing the anatomical. It carries the same accuracy because if there is any change, very minimal change, it fails the case. Okay, and also the software that I'm using will give you all access. Like if you have a knife, they have a plane, it have a lot of tools. I can't explain that. A lot of tools there. So you can do anything that you want to design, develop, because you are not going to create anything. You're just going to uh, develop something existing. For example, if there's a fracture on the right side, you just want to do a mirror. Based on that, you have to just to cement over the defective portions. Okay, so one example, orthodontic surgery, they call it as a facial reconstruction. Probably you may see few people having a lengthy jaw, short jaw, something like that. So they always do a lot of, there are a lot of medical history there. So a lot of reasons they will do this kind of surgery. For this kind of surgery, they just plan only with the tooth model, impression model, and they will have some other software like, I think the software name is Dolphin. Okay, for understand the requirement of the bone movement in front, back. Okay, and they do some bites, same like a splint, manually. Okay, most of the time, it's from the most feedback of the doctors. Most of the time, it won't fit. It fails. They have to instantly work on theta. Okay, so sometimes work, sometimes they can't achieve. I won't say it's success is based on accuracy before the technology came in. Okay, now success is based on more accuracy. Okay, for example, if they are cutting a jaw like this, so it's a very practically it's not possible to place the jaw in, advance the moving front in a 2 mm, not in a centimeters. I'm talking about Okay, 2 mm manually. They will have a small scale over the theater. It's they are not equipped to go in the right way. Okay, that's what technology takes a major role. That's what 3D printing and the softwares takes a very important role to change the complete practice, to giving access or assisting the docters to do their reciprocate their complete ideology into the data. So that's how. So this cuts, you can see a lot of surgical cuts over there. It's exactly what they do it in a theater. So we just reciprocate the all cuts into the anatomical model virtually, and we'll plan, move, we trial error along with the doctor. We finally come up with a solution. So for that complete bite, we give the splint. The single splint will act as a complete guide to work the complete surgical process. So this is a first thing that we started doing in 3D printing in 2015. More than 500 cases, but this gave us a big entry into the level, because before that, few doctors, very few doctors are printing of models. Most doctors will know the name of stereolithography. Okay, they call it as is this a stereolithographical model? That's what. So now this is the first kind of case getting us into the surgical part in 3D printing, maybe our region. So maybe from my point of view, not others. Okay, and virtual planning is like, in BioCAD modeling software, you also have access of to the virtual planning. You can cut the bone, you can design based on the defectivity. Two things you have to consider. One is uh, have to be very conscious on finding out the symmetric structure. It should not go beyond the margin, because we have a skin over that, so it has to be sutured after the surgery, the stitching. Okay, and then second thing, the implant should not be heavy. Okay, so that's part. We involve a lot of structures like, even ma'am mentioned that lattice structures. Uh, Dr. Hariharan also mentioned like, the porous structures to for bone osseointegration, those kind of part. One part is for bone regeneration. Probably I will show you something like that. And another part is for more on reducing implant weight, lightweight and models, so to succeed in that way. Okay, so it's of course when we talk about the structures, now lattice structure is everybody is using for a lightweight, to prepare a lightweight model in metal, and also to give some structures in here, medical application, uh, to increase the porosity, something like that, so that's what it will work. So 3D printing will give you more access on creating a more porous, complex structures, along with better output on success of the surgery. Surgical guide process, probably removing the bone, taking a bone and replacing with existing bone part. So that's a complete workflow. I think I don't want to go much in deep, because just people I will give you overview of what are the works. Of course, in spine also we can do that. Surgical part, for placing screws, plates. Here you can see they call it as a lot of scoliosis cases are there, kind of TBA, I guess. Okay, so they have to place the screws, plates over that, so that it will help more on understanding the bone density, where we can put screws, because most of the cases fails because of they place screws in a wrong position, wrong region. So, porous region, it fails automatically. That's how we can diagnose, and we can prepare a guide to place the screws. Implant designing, obviously, it's a future. We can't. Okay, sorry, it's not a future. It's already happening. Probably it's going to take a complete standard reconstruction plate, mesh into the customized. So that's how it will work. So it's changing a lot. We are doing lot of cases. A lot of people are doing in across the country. More people are aware about the customized implants treatment process. So that's how it works. So it's a small video. So because why I added this video is because how to understand what is BioCAD modeling. So it looks very simple. No, it's not complicated like how we are designing and developing some mechanical part. So we create a plane, we extrude, no boolean, sorry, not a boolean, extrude, we develop something and create lot of intricate measurements, offset, a lot of things like that. But it's so simple it may look. Yes, I say it's simple once we understand the concept. In healthcare, a designing tool will not be a complex way. Okay, understanding the designing methodology is more important. Okay, we can't create anything as like we wish, as like this we thought. Okay, we always need to do a small research study for each part, how we can develop it. Probably we always now we have most template. A lot of people have started doing it. We can easily find out which succeed, which fails. We can do some Google it. You can see a lot of structures are there, but initially it takes it's very hard for us to understand, to design and development, because we don't know, we don't have any clue, we don't have any reference. In 2015, very few people are done, they are not ready to reveal it, whether the case is success or not, whether they have stopped in the designing level, whether they have opted. We don't have any information on it. We just have, okay, we have done this case, we have done that case. Initially it's very hard for us. Yes, obviously we faced one or two failures because of we can't, some patients will not sustain some kind of shape structures. Some patient will have their bone resorption problem. Some patient will have their soft tissue shrinkage. I'm doing it a mechanical part in shrinkage. The soft tissue, the skin will shrink once they cut it and open it. Some automatically. So the bone, when they place the implant, it will expose. Outside, then it fails because of that. So this the video that you're seeing is we call it a subperiosteal implant. It's a new concept, not a new, it's a 5 years old concept. When we do first time, it's a new concept. We have a lot of plus and minus feedback. Somebody asked us to stop it, don't do that. But a few doctors have their command, but most doctors will support us to do cases. Now, subperiosteal implant, a few of my ex-colleagues, Dr. Karthik sir, he has his own company doing implants. He's doing 30 to 40 cases per month, this kind of implant. Okay, so that's how it will grow. So we have to little taking. So of course we did a lot of validation, analysis, those parts together. So this is how BioCAD modeling will work. So designing, it's more on application-based designing. We have to understand the bone, where it works, how it works, what is the nerve considering, surgical part. We have to get feedback from the surgeon. We go based on the surgical limitations is there. You have to consider that, and more symmetric on shape structures, and also it won't fail. The weight has to be lesser. At the same time, model should not be much bulk. We give structure. Osseointegration will not work in all the applications. Sometimes it works, sometimes it's not needed, but we implement some structure to reduce the weight as well. At the same time, we have to consider about a lot of force, biting force, right, things like that. So we have to consider, we have to design something like that. Okay, so this is how even BioCAD modeling will work. So image processing and BioCAD modeling will help you to convert and design. I just add one more topic. It's also including the BioCAD modeling. The software that recently that I'm working with, I became a big fan of the software, N-Topology. Probably you can Google and you can see it. This software changes a whole designing process. For example, my research is on lattice structure. Okay, so I designed some lattice structure. When I seeing this, it reduces my complete work. Okay, it takes us to find the methodology, takes us to clean the methodology about a year, but we can do all the things in half an hour to 30 minutes. So the main thing is it will give you the access of developing structures more lattice structure, complex shapes. You can implement a lattice structure in any part, mechanical as well as medical grade parts. Okay, so it works in a different industry. In respect to healthcare, of course, it works on more. I think people are aware. File size. It's a big task when you are going into the more tiny structures. Lattice structure. Those things. The file size became very heavy. Okay, this software will reduce the completely reduce GB to KBs, and also have a complete control of working on the structures, shapes, and everything, and also you can go beyond the design structures. You can tribacular structure is a bone actual our natural bone porous, having a porous, the porous level part is a tribacular. You can create something like tribacular. Recently I have done uh, one tribacular design for a vestibular cup, one of my clients. So I was surprised. Okay, so it as to 10 to 15 steps I developed for it. Okay, created the various parameter, pore size, interdistance, everything. So but the final output is I have a complete control on it. For example, if we have this kind of mesh structure, we don't have a control on where it connects, how it connects, and everything. But this software will give you control on each and every part. I know where it connected, what is the thickness of the connection between each and every latticed mesh into that. Okay, so applications like it gives you more than lattice structure. Sorry, I talk about only lattice structure. It also give you the topological optimization option. You can do automatic topological optimization based on the shape, structure, and do. Of course, ma'am mentioned this about the topological optimization. It's does automated software, and also lattice infilling, varying shells, and also there are a lot of things out there. Customized shape, patterning, lattice structure, structuring, and also you can do some design analysis, FEM analysis. I'm not much aware about it. I'm learning the software, but they are also doing some FEM analysis. I'm not much deep to understand it. So I'm just finished 2 days of course. So I just like to show you this. Okay, and also the main thing is the working tree. In our traditional CAD software, we have a lot of steps. Okay, when there is a we have to change the parameter or something, you have to do it from first, or so you have to repeat something. But in this software, once you develop the complete workflow, whether it is a 20 or 25 steps, okay. So for example, I have created a vestibular cup with a lattice structure, tribacular lattice structure with parameter of 10, 5, something. Okay. If I want to change a parameter, I don't want to change completely. I can directly go. I have a input there for the I have a option for input of the pore size or something. If I change it, it automatically changes to the complete workflow. I don't want to repeat it to check everything. So once I change it, it automatically works. It loads to each and every step. It automatically gives you the output with a different parameter. At the same time, not only the parameter, I have created a complete workflow. Okay, I have designed a vestibular cup of 52 size. Okay, and then I have to design another vestibular cup with lattice structure of 54 or 58 size. Okay, I don't want to repeat the process. I just remove the basic mother data from 52 and then I import the 54. The whole thing can be copied into that. I will get the output in minutes, less than a minute. So that's how it's easy. Please try. Obviously, they are also giving some trial for the research base. Probably please try and do some validation as well. Okay, so this is what software takes a part. And I just, as I mentioned, I have run through a fast, about the materials and machines that we use. Okay, as a regular practice, printers are modeling everything, each and every case. What are the material I choose for each case based on models, implants, and instruments that I use. I just want to show it. I think we have a time till 4, right, sir?
Yes, sir.
Yeah, thank you. Okay. Of course, I don't want to explain about each technique, so I just go straight away with the different techniques. Okay, SLA, we have a 3D system machine in-house. You can print a transparent model and also dual color. So it highlighting the color. That's how it will show. It will give you the bone model along with the internal structure. Can find out how the porous bone different densities internally. Based on that, they can plan the surgery model. And one more thing, as I mentioned, talking about the choosing a material, we have to choose compatible material for healthcare. Okay, compatibility, there are two things are there. Not based on the textbook base, I'm just saying a commercial way of using. Okay, compatible to use inside the body, compatible to place inside the body. Okay, compatible to use inside the body, the material has to be certified biocompatible. It won't have any toxic things inside, so we can use inside the patient, or we can get the model into the operation theater. That's what compatible to biocompatible. That's material having a photopolymer is there. mm, Photo liquid based material is a powder based polyamide is the polymer based materials, nylon something. Okay, and also we have some other powder based material in our MJP CJP technology. In FDM, of course, we can say PLA is also compatible. I think never used much on the FDM models. Initially we did so, because we can't use FDM for the surgical models, because those models will not sustain autoclave heat treatment, because when getting any part into the operation theater, or any part using into the patient, we have to do some heat treatment. I think now you more aware about autoclave sterilization. Okay, we have to do sterilization before using it. So those FDM models will not sustain the heat process, it will deform. So this is a material transparent, you can use it for models with the internal information in a transparent material, and also as a biocompatible model, you can use it for surgical guides, those things. Figure 4, of course, technology, so machine, no, new machine that recently launched. Not new means not 2-3 years before. Okay, but in healthcare, this is an entry level machine who is having a biocompatible certified material, will sustain high temperature. Okay, and also it's authorized certified to do autoclave at sustain 100 degrees Celsius for a period of time. They have some template. Two materials is that, one is transclusion and white material. Because why I'm mentioning this is, before that no material has been much certified. They say it like, biocompatible, but there are in biocompatible, so there are different things. So some material has been certified to use orally. Okay, even biocompatible is food graded, something like that. So you can use it as a dental guide. That should be in a contact of our saliva or mouth. Okay, that's what they are certified. But we can't use that material into the open wounds, right? Spine surgery, orthopedic surgeries, facial, maxillofacial surgery. It can't be placed inside the human body for a time. Okay, this material is compatible. You can use inside the open wounds as well, because it's certified for it. Okay, two different ways. So even 3D System and a few of our partners, they have developed a surgical instrument with this material. Okay, so it's a kind of machine instrument. You can see it here, some saline supplying machine onto the surgical part. SLS technology, probably much aware about the technology. So this technology we use on more complex shape structure that we want to print it, because it's no support. It will give you more on that. At the same time, it's as a material is purely biocompatible. At the same time, the large models like orthotics and prosthetics. So orthotic and prosthetic is a huge chapter. Okay, so you can a lot of things are there: hand braces, prosthetic legs, neck braces, spinal braces. A lot of things are there. So those kind of things, of course, there is a part you can externally scan it. Okay, we represent Zyscan, called Zeiss. Probably you know that, one of the oldest company in this field. Okay, and then Geomagic, we can also use it for orthopedic. A lot of people are using it for orthopedic. Probably one of the example is Additive America. Those who are more active on LinkedIn, you are aware about Additive. They are using other software. So you can print any prosthetic on that. So 3D System, of course, they have some CE certification for our SLS machine along with material, so that our clients don't need to get their certificate. They can use the certificate. We will give machine along with the certification. So some application, you can see it here. CJP, I just like to show multicolor material. It's a pure model level, more on patient education, mock surgical planning, those things. It will give you the multicolor. There are a lot of machines. So the HP is also having a multicolor, I guess. Coming to metal, of course, it's ultimate. 3D System is a company who has been developed metal machine for healthcare application. Then they have come into the other application. But our initial and main long-term focus is healthcare also. So we work more on healthcare. Currently, recently, I think few people may follow, may aware. our CEO, I think, who's the inventor of the technology, SLA technology. So he's now not no more a CEO of our plastical metal company, 3D System main we have divisions. Now we also acquired a company called Aliva Bioprinter. So he became a CEO of that. So he started working on bioprinting. So metal, of course, I would say, rather representing a company, I'm a big user of all the products, technology for my 6 to 7 years, and also I have printed all my implants, in 3D system. Initially, we get printed from Luan, layer voice, now it's, after 3D system acquire it. Okay, so we have a two setup, one is in Luan and Denver. So we are a official printing partner for Strikers and Johnson & Johnson. So we print, of course, in our Luan setup, we print, of course, 500,000 of implant every year. We have a dedicated machine, the same 350 and 350 factory is two different machines. So we have a dedicated machine labeled in the name of Strikers, in the name of Johnson & Johnson. We run 24/7 for them. We are the printing partners, and we are into the printing field for healthcare more than a decade. Some samples you can see here, some printed implants. And also this another thing, probably whenever we talk about implant or anything, always we talk about titanium. So in dental, maybe we can talk about cobalt, chromium, stainless steel is very earlier. I won't recommend that, but maybe for instrument you can use it. But what is next? Probably next is already there, ceramic printer. We also represent this company. They have done nearly 10 years of research-based work. They have done a lot of case studies to validate. They have done a lot of real patient cases to get certificate and those things. So this printer is a kind of SLA technology, but it works in a different way. They have a biocompatible materials. Different application. Of course, we focus on healthcare. They have a material hydroxyapatite. Okay, you can print non-load bearing implants. Of course, we can also use it for little load bearing, not in orthopedic as well. They are in a research on, but most on craniomaxillofacial applications. You can do that. You can do scaffolds, so that you can do some laboratory test, validation, and you can implant into the patient for HAP. And also they are also having a material called zirconia and tricalcium phosphate, and also they are going to launch few more materials as well. As I mentioned, of course, bioprinting. Bioprinting is in a research level, not in a direct usage level. So currently they are developing some scaffold, some soft tissue part to do some research on development and creating, and also currently more thing has been using for the to test drug testing, to test the materials based on the material. For example, these are the bioinks they are having. For each organs they have a different bioinks. Okay, so this is not okay. We are not in that stage. We can't print organs. For example, if somebody is developing some medicines or some drugs, something like that, potassium, right? Sorry, something like that. So they can test into it before animal testing. For example, if it is a liver, so we have a different materials. So you can develop or grow a print organ, something in the shape or any shape. Okay, this material will act like liver. Okay, so whenever we are testing a material, it will respond based on the material, whether it is accepting or anything. It's purely on research level. But now it almost we are reaching into a developing small skin tissues or something. Okay, they are in the development and they are doing a lot of scaffolds, and also medicine testing is a major thing that they are doing. Okay, probably this is a company who is a very finer. They are doing long-term work with the things. Recently, we 3D System acquire. Of course, once 3D System acquire, we started working with them. Okay, so they are almost in the development. Probably we can say 5 to 6 years. We can see something on scaffold organ development, something like that. Okay, so this is what different machines, materials that we choose, and we work on that. And then I would like to show some real examples. Probably this is my more study, my research. I no, it's done a kind of a tissue engineering based scaffold structures for orthopedic application under my guide, Dr. Armikana Madam. Okay, so of course, this is what the complete workflow. So I just at the time we are able to develop some structures, different unit cells we created. I did nearly 140, 150 different patterns, lattice structures, starting from basic primitives, crystal structures, lattice structure, a lot of things. Then we validated the porosity value and also printing feasibility based on that. And finally, we choose materials. Since a laboratory test, I choose a selective laser sintering technology, a polyamide biocompatible material. Okay, this material is not compatible to place it, compatible for using for research development, those research works. Okay, so you can see the final output. These are the two structures that I'm able to achieve more porosity. Okay, porosity is a kind. Okay, I think Dr. Hariharan has covered about porosity. I would say simply higher in porosity will give you better bone growth. At the same time, porosity is a one point. We can also make sure there should be some good mechanical property has been involved as well. So to validate it, so I did a MTDSA test. So it's a kind of laboratory-based cell culture test. So we just put a samples of scaffold structured bone and non-scaffold structured bone into the wall plate. Okay, some laboratory testing plate. So we feed some bone cells into that, and then we incubated it for some period of time. After incubating, there is a small procedure over there. So based on the study, okay, finally I conclude that okay, the sample with scaffold structure and without scaffold structure, and with scaffold structure is orthogombic scaffold structure. Shows that I'm getting more than 65% of porosity. It gives me 3 times higher in the cell growth. For example, if you are giving an implant without any structure, as a solid thing, it will sometimes it fails, sometimes it will give you take you 6 months of better adaptation. But this scaffold structure implant, we are placing it, it will adapt very quickly. Okay, so 2 months, 3 months, it will osseointegrate inside it. The bone will generate inside the implants, and then it will get more adapted. Of course, we can't remove the bone implant, okay, but it will get more adapted, reduce the failure. I'll act like a, as Hariharan said, like it will become your friend easier. Not it won't take long time. Okay, probably without a chocolate. That's what I say. Okay. So, and also I would like to, okay, I have done my complete presentation about it. I have some cases with me. Probably, okay, it's a confidential. I can't share it in a commercial platform. Probably, I can't show it, but sometimes I have access of showing into the non-commercial activities for institution research base, because we can say a lot of things. We can do that